Our next topic for fractions is division of fractions. So when you take two fractions and you're trying to divide them, the easiest thing to do is to change the division problem into a multiplication problem. And we're going to use the phrase multiply by the reciprocal. Reciprocal means the top goes to the bottom and the bottom goes to the top. The numerator and denominator switch places. So for example, we have a over b divided by c over d. I'm changing this divide sign into a multiply sign, and I'm going to flip the second fraction. Okay? So the phrase you can also use is flip and multiply. There should be a L there. So it's always the second fraction that you're flipping. Okay? Leave the first fraction the same. So when I have 1/2 divided by 3/5, that's really 1/2 multiplied by, I'm changing the divide to a multiply, and I'm changing the 3/5 to 5/3. Now I can multiply like I've did on the previous part. So I multiply the top, I get 5, multiply the bottom, I get 6. 5, 6 can't reduce, so I am done. Our next problem, we have 3, or you can think of it as 3 over 1 to remind you that it's a numerator. I'm going to change that divide sign into a multiply sign, and I'm going to flip the second fraction. Only the first fraction stays the same. So 2/3 becomes 3/2. 3 and 3 doesn't reduce with 2 and 2, so I can just multiply across and get 9, and multiply across and get 2. On our next problem, I have 15 over 7 divided by 5. So I'm going to change that divide into a multiply, and the multiply by the reciprocal. Now 5 you can think of as a fraction, as 5 over 1. So when I flip 5 over 1, I'm getting 1 over 5. I notice now that 5 and 15 have a common factor, so I can divide those both by 5. So 5 divided by 5 is 1, 15 divided by 5 is 3. Multiply across the top, 3 times 1 is 3. Multiply across the bottom, 7 times 1 is 7. And 3/7 can't be reduced anymore, so I am done. On our next problem, -6 over 35 divided by 33 over 55. So I'm going to change that division into a multiplication. And the 33 over 55 is going to flip or reciprocate into 55 over 33. Now these are big numbers. There's a couple different ways you could do it, as we discussed before. I'm going to go ahead and try prime factorization here. -6. 6 is 2 times 3. The negative just stays there, okay? And a negative times a positive is going to be a negative anyway, so I know my answer is going to be negative something. 35, that's 5 times 7. 55, that's 5 times 11, and 33 is 3 times 11. Now anything in the top with anything in the bottom that has a common factor can divide out. So 3 divided by 3 is 1, that can divide out to 1. 5 divided by 5, so the two 5's can divide out. And then 11 divided by 11, that's 1, that divides out. So what do I have left? A -2 over 7. On our next problem, we have -3 over x. Multiply by, I'm changing the divide 9 over x squared into multiply by the reciprocal, x squared on top and 9 on the bottom. Remember that x squared is really x times x, and 9 I can rewrite as 3 times 3. So that means the 3 divides out with a 3. Now there's still a negative here. If you want, you can consider it to be like a -1. The x and the x divides out, and so you're left with -1x over 3. Another way of writing that correctly is also -x over 3. You don't necessarily have to have the 1, but it sometimes helps people understand that a little bit better. Next, we're going to be adding and subtracting fractions with common denominators. So I'm going to start with the common denominators, and then we'll go to the denominators that are not the same. If your denominators are the same, so we have c and c, okay? All you have to do is keep the denominator the same and add the numerators. Or subtract. Notice that it works for addition or subtraction, but all of the denominators have to be the same in order to add or subtract. For example, 4/9 plus 3/9, the 9's are the same, so they stay the same. And then you add the numerators, 3 plus 4 is 7. If 7/9 would reduce, you always want to reduce at the end of any problem. If you can reduce, you better do it. But you can't, so we're done. 13/16 minus 15/16. The 16 are the same. Hooray! So the 16 stays the same. And then I'm going to add or subtract the top. In this case, subtract. 13 minus 15. Notice they're opposite signs. So I'm going to subtract and get 2. And because the 15 is bigger, I'm going to take its sign, which happens to be negative. Now this can reduce, so I'm going to divide the top and the bottom by 2. That leaves with -1/8. Now the funny thing about negatives and fractions is you could write -1/8. You could also write 1/-8, or you could write -1/8. These are all the same thing. The negative can technically float to the top, to the bottom, to out in front, as long as you only have one negative. The least desirable of them is this one, the underlined one, the 1/-8. Some books don't really like that. I don't really mind if you have the negative in the bottom or the negative in the top or out in front. I'm kind of pretty easy that way. But some teachers in your future might not like the negative on the bottom, but I'm okay with it. Our next problem, 12/14 minus 19/14. Notice that the bottoms are the same. Hooray! So keep them the same. Then I'm going to add or subtract the tops. 12 minus 19, they're opposite signs, so I subtract and get 7. Because the 19 is negative and it's larger, I take the larger value sign. 7/14, I can divide the top and the bottom by 7, and that gets you -1/2. Again, the negative can go on the top, the bottom, or out in front. Okay, look at here, we have 3 7s in the denominator, but no big deal. As long as the 7's on the bottom, it stays in the bottom and it's the same. What we're going to do though is we're just going to do 2 at a time. So let's just go left to right. 3 minus 6, opposite signs I subtract, take the larger value sign, which is negative. So that's 3 7s minus, I still need to do 4 7s. So the 7s are still the same, it stays the same. -3 minus 4, that's same sign, so I add the 3 and the 4 makes 7, and I keep their common value, which is negative. Now -7 divided by +7 is -1. Next I have 3/x minus -7/x. So the denominator this time is a variable. No big deal. As long as the denominator is the same, it just stays the same. Minus a negative though, whenever you have a minus and a negative, that's add a line and change the sign. So I really have 3 plus 7/x, and 3 plus 7 is 10. So I added the tops and kept the bottoms the same. Same thing for -5/y minus -2/y. They both are over y, so they stay over y. I do have 2 negatives next to each other, so add a line and change the sign, so that gets me -5 plus 2. Those are opposite signs, so I subtract and get 3, take the larger value sign, which is negative, and I'm still over y because the y doesn't change. As long as the denominators are the same, they stay the same.